Welcome everybody. My name is Dr. Steve Offley and I'm the Product Marketing Manager at Phoenix Temperature Measurement. I would like this morning to present a short video to introduce to you a new innovative design from Phoenix Temperature Measurement, which we're introducing to help with the temperature monitoring through process temperature monitoring of the T6 aluminium solution heat treatment process. Phoenix Temperature Measurement has for many years offered a through process monitoring solution with the TS06 thermal barrier design, similar to what you can see on the slide at the moment. What we would like to introduce this morning though is a new concept that we've introduced for sealing the thermal barrier in a far more efficient and easy methodology. The new seal will be based on a silicon rubber gasket, as you can see in my hands, which makes sealing the thermocouples significantly quicker, easier, but with the reliability and robust nature that you have come to know and accept from Phoenix designs. Before we go on to the actual design of the new thermal barrier, I would like to just make sure everybody's clear on what we're trying to achieve with this new design introduction. Obviously, we all know that aluminium in its pure state is a very soft metal. So in order for it to be used for products like engine blocks or alloy wheels, we often have to process the aluminium to add alloys which are dissolved into solid solution. These alloys create obstacles to the dislocation movement of the aluminium atoms in the matrix of the metal. This gives structural integrity and added strength. In order to add the alloys into the material, we have to perform the heat treatment precipitation hardening process, where we control the solubility of the elements, the alloys, in the aluminium by changing temperature. In the T6 process that you all know, this involves heating, rapid cooling, and then aging of the aluminium material. For all of these phases in the heat treatment process, temperature control is critical, and a key part of that process is obviously the ability to monitor the actual product temperature as it travels through the process. We need control and we need uniformity to give the aluminium the properties it needs for its end use. To summarize the three phases of the T6 process then in this temperature profile schematic, we have our solution treatment phase, which is typically 400 to 500 degrees Celsius, followed by a very rapid cooling of the aluminium matrix in a water quench, and then a subsequent aging process at a lower temperature, typically 100 to 200 degrees, and then an air cool. Obviously, to monitor the aluminium as it travels through the process, the T6 process in this case, we need a system that is able to travel with the product. And in this schematic you can see a typical product basket containing aluminium alloy wheels. The Phoenix system you can see is there contained within the product basket with the wheels, and thermocouples attached to the data logger inside the thermal barrier are then positioned on the product or in the core of the product where the process engineer needs to measure the actual temperature. The system is able to travel through all of the process, so that includes the solution treatment, the water quench and the age hardening in one continuous step. protected from the hazards of the process, the heat, but obviously in this particular case also the challenges of being quenched into the water bath and requirement for waterproof protection or IP protection to the data logger and the equipment being used. To give a little bit more detail to the thermal barrier that we use to protect the data logger, on the slide you will see a schematic of the thermal barrier and a photograph of it assembled, ready for use. To provide thermal protection to the data logger, in this case we would use a high temperature data logger which is able to operate up to 110 degrees Celsius safely and accurately. We employ what we refer to as phased evaporation protection technology. To put it simply, we use a water tank to keep the temperature of the data logger below 110 degrees. Water in the water tank itself, as it enters the thermal process, will heat up until it gets to obviously 100 degrees. It will boil, but obviously at that temperature, the temperature will be maintained at that level. That temperature being less than the maximum operating temperature of the logger, so the logger is then maintained at a safe temperature travelling through the process. The data logger is therefore protected whilst there is water in the water tank, and the size of the tank is therefore designed and constructed to satisfy the length of the process you want to monitor. One of the key requirements of the water tank technology is that we need to protect the data logger from water as it enters the water quench tank. And as you can see on the schematic, there is an arrow pointing to the watertight joint which allows protection of the data logger inside the tank and no ingress of water into the area where the data logger is sitting. The water tank is surrounded with an insulation blanket and then an external structural metalwork frame. The insulation blanket is used to give further protection to the structural integrity of the thermal barrier and overcome problems of distortion or warpage, which could be expected due to the rapid temperature changes you see from going from the solution furnace to the water tank. Historically, the TS06 thermal barrier has used as a means of providing waterproof protection or IP67 protection to the data logger a compression fitting design. As you can see here on an existing data logger tray, the compression fittings are positioned on the front face. The thermocouple is routed through the compression fitting, but as you can see from the photograph, the components are relatively small, fairly fiddly, and one big challenge you have is that you can't fit a coiled thermocouple through the fittings. You have to uncoil it. It needs to be perfectly straight to feed it through the length of the compression fitting. If you have a cable that is 4 meters long, that can take some time. It's, to be honest, tedious. It's a little fiddly, and it adds time to the setup and the construction of the thermal barrier. So what we need is an alternative to the existing compression fittings, but that gives us no degradation in the waterproof protection that the compression fittings have historically provided. This leads us to the new design concept I want to now focus on, which we've included with the TS06 thermal barrier. At the heart of the new sealing mechanism, we have a rubber compression seal. You can see here it's a rubber block which is split into sections which are designed into which the thermocouples will slot. Very robust, can cope with the temperature of the process, and as you can see, it's very easy to part these and simply insert the thermocouple, and I'll show you in a couple of minutes how easy the setup process is in practice. The compression fitting fits into a front faceplate which is connected together, and that fits then on the front face of the data logger tray. At the end of the day, we believe this new design provides a unique, innovative methodology for sealing the TS06 thermal barrier. It allows easy, quick setup and also IP confidence. So you have still the guarantee that your data logger is protected as it enters the water quench system. What I would like to do now, ladies and gentlemen, is show you with a very quick demonstration how easy it is to install the new gasket seal to the front faceplate of the data logger tray used on the TS06 thermal barrier. The first operation is to take your MI thermocouple. As you can see here, I'm going to use for the demonstration a coiled thermocouple, which is obviously beneficial for most applications because it allows you to transport the system around very easily. So I need to insert that into the faceplate of the thermal barrier data logger tray. I insert it and then invert it 90 degrees. I can then insert that into channel 1 of the data logger easily and efficiently. Place the data logger in the bottom of the tray. Make sure that there's enough space at the back end of the tray to allow some adjustment of the thermocouple at the front face. I then take my thermocouple gasket with the bottom metal section into which it's inserted. To install that, or install the MI probe into that gasket, I simply position it close to the front faceplate. I find the slot that is allocated for the thermocouple. You'll see here that this is slot number 2. Slot number 1 is generally used for the RF antenna if we're using RF telemetry for the system. So slot 2 is for the first thermocouple channel that we're using on the data logger. To insert the MI, I just simply align it with the slot and then gently with my fingers simply push into place until it engages neatly at the bottom of the thermocouple gasket seal. It's as simple as that. The next thing I do is I position it close to the front of the faceplate, and I take the top section of the gasket seal, the metal housing, and I'm going to just simply insert that over the gasket seal. Simply slots on nice and neatly, as you can see. I then take the 2 longer bolts and I insert them into the 2 holes on the top face. You can start to engage them by hand, but you then use the Allen key to fully secure them into place. No need for any torque settings, no need for any expensive tools. The important thing is to engage the bolts fully into the housing so that you are compressing the seal and you have a nice parallel mating face. Just simply tighten as far as it will go. The next step of the process is to take the faceplate of the data logger tray and mate it with the inner faceplate of the silicon gasket. I simply take the faceplate and engage like so. I then take the shorter bolt and engage in the front face. For the purposes of the demonstration, I'm just going to secure the 2 top bolts, but it's the same principle for all 4. Using the Allen key again, just simply tighten. So you've got a nice mating surface at the top here. Ensure that your logger and your thermocouple is connected neatly in the front face, and your seal is now ready. We then have a nice sealed faceplate for our data logger tray, which can be inserted into the water tank, where a second gasket seal is used to seal this faceplate to the water tank. As you will have seen, assembling the new compression fitting is very simple, very quick and economic. Once in place, the compression fitting faceplate is assembled on to the front of the logger tray, as you can see in the photograph, and that slides into the thermal barrier, where the second gasket provides the sealing to the front face of the water tank itself. In conclusion then, ladies and gentlemen, we believe at Phoenix Temperature Measurement that our new design of faceplate for the data logger tray will provide you with significant benefits for your T6 monitoring requirements using the TS06 thermal barrier. Just to summarize the benefits, we believe that it will allow you quick, easy installation of thermocouples, and if you're using radio telemetry, an RF antenna. If thermocouples aren't being used, you can also blank off the necessary channels with blanking pins. The thermocouples can be fitted conveniently, even in a coiled state, and that obviously will provide benefits for moving the system around in a more compact fashion. As we've highlighted previously, there are no fiddly compression fittings required as we've provided historically, which makes handling the equipment that bit easier in an industrial setting. There's no need for tools or small components. One major benefit of the new design is that because we're not using the compression fittings anymore, you can remove the thermocouple from the gasket without damaging the thermocouple. This will reduce the amount of wastage and obviously consumable costs if you're doing repeat thermal profiling or monitoring of your process with the same bit of equipment. The seal is designed in an innovative way that it provides what we refer to as a bidirectional seal. So it's sealing around the thermocouples, but it's also sealing to the front faceplate of the data logger tray. One major benefit of the new seal is that also we can provide the new seal as a retrofit to existing barriers. So if you're using the historical compression fittings, you could replace the data logger tray with the new design using the rubber gasket and gain all the benefits of that new design principle. To finish then, ladies and gentlemen, I would like to thank you for your time, and I hope that what we've shown you this morning with the new innovative design of the faceplate, the new gasket seal, will be of interest to you and your temperature measuring monitoring requirements for the T6 process. As ever, we hope that the through process monitoring solutions we provide at Phoenix Temperature Measurement give you the value you need to improve your processes, to find, fix and forget your furnace problems. Thank you and goodbye.